Good day, my wonderful great tens. Today we are back here to learn about the transverse waves. Yes. So first and foremost, I would like to reiterate this definition. I want it to stick inside your mind. So because these definitions can help you a lot to gain more marks on your examinations. So what is a transverse wave? It is a type of wave where the movement of the particles of the medium, remember, they move what perpendicular to the direction of the wave. Yes. Hopefully that is understood. But then the definition may differ due to district. So when just adhere to what your teacher tells you to write, yes, just adhere to definition that you have been given and make sure that you learn it and make sure that it sticks so that in the examination you can just draw it down in the exam room and get it over with. Yes. So actually today's topic is about wavelength, understanding what is wavelength. So wavelength, it is the distance between two. You see, I want this to stick inside your head. It is the distance between two successive points in phase. Yes. Please do not let this word successive get to you. The word successive just means one after the other. It just means that they are following each other. They are successive. You know. So yes, we measure wavelength in what? In lambda. Yes. So first and foremost, I like to remind you the concept of what? A crest and a trough. So a crest is just like the top of a mountain or the top of a wave. Yes, this here. The top of the mountain or top of the wave. And a trough, that is the downhill or the downwards of a wave. Yes. So the trough is situated right here. So as we go back to the meaning of successive points in phase, yes, as you can see that here we have one crest and we have the other here. So we have two crests that are following each other. I mean that the crests are what are successive. Yes, that's why they're saying that the wavelength is the distance between two successive points in phase. Also, the trough is what? Successive, because there are what? Two. Yes. So here, number one, number two. Yes. So what is a wavelength? The wavelength is actually the distance between this first one and the second crest. Yes. So this distance here, that is what? The wavelength. It is measured in what? In lambda. And the wavelength can be also measured in what? In the trough, which is the downwards of the wave. So it can also be measured as what? The wavelength here, from this point to the other point, because that what? That's successive. So let's do a little activity just to give you some more understanding of what is wavelength. So I want you to look to draw down and look at this diagram. So here we have what? A crest. As you can remember, the crest is the top of what? Top of the wave. And we have down here we have what we call a trough. It is I don't know how you want to call it. It is where the wave dips down. It is the downward heel of the wave. Yes. So remember that in order to form a wavelength, you must have two successive points that are in phase. So yes, this first crest, the top of the mountain, and this second crest, the top of the mountain, are following each other. I mean, they're successive points, and they are what? They're automatically in phase because they're following each other. Yes. So the distance between here and here is going to give us what? The wavelength. So if we can look properly, we have been given numbers. You can see here 10, you can see here 5. So all we need is the difference between 10 and 5. And yes, 10 minus 5 just equals to what? 5. So meaning that the wavelength is going to be what? Is going to be 5. Yes. And remember, I want you to remember one thing. Wavelength is the same all over. Yes, meaning that the space here is the same for the space here at the bottom, which is the trough. So meaning that also here it is the same space. Yes. The problem with that, with this diagrams, that they did not give us numbers here. But if there was a number here and a number here, that's going to be the wavelength. But then you have to what? You have to minus. For example, let's say they give us 7 here and they give us 12 here, because obviously they must equals to the wavelength of 5. So 7 minus 12 equals to what? 5. So the wavelength, it is consistent for all all this wave, you could say. So it is, remember, it is always consistent. So that is the wavelength. So my great friends, I hope hopefully that lesson was clear and crystal and short, because the wavelength is a short concept to understand. If you didn't understand this, repeat the video or comment down below so that we can help each other and see how we can make your life more easier. Yes, and I thank you for tuning in to this beautiful lesson, and I hope that you pray, you practice, and you go and excel in that examination. Good luck, my first students.